Hi, I'm Chuanyin. My ZID is Z5423180. Kepler's law is the final solution to the problem of planetary motion, which is one of the foundations of astronomy. So Kepler's first law is the planets move in elliptical path with the sun at one focus. And Kepler's second law is the law of area, the line between the planets and the suns without equal area in equal time. So Kepler's third law is the square of the optional period of the planet is proportional to the cube of the semi-major axis of the orbits. Now we move to question 9. When the moon orbits, the planet is not completely motionless, as the planets will have slightly movements as the moon orbits. So in question 1, 4, and 7, the mass of the sun is much greater than the planet, hence the center of the mass is always inside the star, and however, its precise location shifts slightly depending on its mass ratio. In question 1, the center of the mass is deep inside the sun, close to its center due to the sun's overwhelming mass. And in question 4, by increasing of the planet's mass shifts the center of mass slightly toward the planet. And in question 7, increasing the sun's mass moves the center of mass closer to the sun's center, strengthen the mass imbalance. So, in a planet-moon system, the center of mass is near or inside the planet, as a planet's mass is tens to hundreds of times greater than its moon. And in contrast, in a star-planet system, the center of mass is much deeper inside the star, because a star is thousands of times more massive than a planet. And for question 11, in reality, the Earth-Sun distance is 1 AU, but in this simulation, this distance is 2 marking, thus each marking is 0.5 AU. So for question 14, when the planet's distance at 0.5 AU, the orbital period is 115 Earth days. When it's at 0.75 AU, it's 246 Earth days. At 1.25 AU, it's 373 Earth days. At 1.5 AU, it's 490 Earth days. So this confirms the key principle of Kepler's third law. A planet's orbital period increases as its distance from the sun increases. So this relationship arises because a planet further away from the sun will experience a weaker gravitational force, and only requires a lower orbital velocity to maintain its orbit. Therefore, the planets take longer to complete one revolution. And this simulation also visually demonstrates this. As the planet moves further from the sun, its velocity decreases, and its orbital period will become longer, further showing the Kepler's third law. And now we move to question 15a. The planet with the faster orbital velocity in our solar system is Mercury. Mercury is closest to the sun, and it has the smallest semi-major axis and the shortest orbital period. According to the Kepler's third law, planets with the smaller orbital radius have the higher velocities. And also, Kepler's second law states that a planet moves faster when closest to the sun, this further supporting this conclusion. And for question 15b and c, the planet with the slower orbital velocity is Neptune, and it's the furthest planet from the sun. Neptune has the largest orbital radius. It experiences a weaker gravitational pull from the sun. According to the orbital velocity formula, velocity decreases as the orbital radius increases. And Kepler's third law also shows that a longer orbital period will have the slower velocity. Therefore, Neptune moves the slowest among all the planets in the solar system. So, after I finished all the experiments and answered all the questions, I found these assignments provide me a clear understanding of Kepler's laws, especially the Kepler's third law, which I used to find abstract. And the third law demonstrates the longer orbital distance leads to a longer orbital period and a lower orbital velocity. Also, I learned that all celestial bodies orbit around a common center of mass, and this reflects the gravitational balance within the system. And finally, I observed the impact of mass on orbital motion in this experiment, which shows the role of gravity in shaping planetary and satellite orbits. And this is the reference. Thank you.